Hello class, we're ready to start week 2. I hope that you've been successful at setting up Revel and all of the other things, hypergrade, getting everything set up on your computer, your Java environment. Great job. I know there's a lot to do there. For week 2, we're going to be looking at chapter 2 and chapter 4. So if you go to the modules section in Canvas, you'll see that there are links to the textbook PowerPoints. You can look through those if you like. The links in those to the animations of code and things should work, but we're going to look at the content through Revel. Now, before we go do that, you have a few assignments for this week. You're supposed to locate instructor feedback, and notice that this assignment is not due until September 12th. Because this is dependent upon me getting some feedback for you to look at. So I want to give you time there. Then we have an assignment in Chapter 2, Exercise 11, and that is a population projection. And then we have a body mass index calculation in Exercise 2.14. Now, both of these will be due in hypergrade, and you'll be filling out the program submission template to add your code to Canvas so that it can be commented on by the instructor. And then you'll have a quiz for over chapter 2 and 4. Now let's take a look at that content in Revel. We are running the September 5th content. So I'll click on that, and remember that this weekend coming up will be Labor Day weekend, so you'll want to get these assignments done and turned in early so that you have the weekend off. Otherwise you'll be working all weekend and you'll be sad. Now I'm going to click here at the beginning of chapter 2. We're talking about some programming basics in this chapter. Be writing some nice Java programs that have some input, a small amount of processing, and then format some output. To do that, we're going to use some data types and define variables using those data types. We'll also be able to define constants. We'll look at how we use operators and expressions in Java and how to process input and output. Now, at this point in Revel, they show you a simple program, and I want to show you how this is set up in Revel. First of all, they remind you that all Java programs are surrounded by a class, and a class begins with an open curly brace and ends with a closing curly brace. And then we always have a main method, and it's formatted in this exact same way every single time. Here we show some comments for what our program is going to do, and then we're going to be adding some code to this program. Now, this is a really cool feature of Revel because this is an example that's embedded in Revel. We can start it as an animation, and Revel will walk you through each line of code, giving you some nice information about what's happening here. So the program starts execution from the main method. I click next, and it says, oh, this is declaring a variable, and this variable is named radius, and it's going to be a real number, a double, meaning that it can have a decimal place. We'll be looking at those data types here in a second. We continue on. If we click next instead of previous, and we see another variable being allocated and what's happening in memory over here for these variables. And then we execute the line of code that assigns a value to radius. So we see that value get placed in memory for our radius variable. Then we have a check your understanding, and it's asking us what is going to be the result for area if we take radius times the value of pi. I'm just going to click OK, and it's going to say wrong and tell me what the answer will be. We could get our calculator out and do that math. And then as we continue on, it continues walking us through every line of code in this program to explain that output statement. Now all of this is a little new. We're going to be talking about all of these different lines of code here in this example. But basically I want you to see how in Revel you can use these animations to step through the code. You can also compile and run the different programs within Revel and see what's going on and try some different things, different variable values, and try different stuff. So it's a great feature for you to use in Revel. Now if you're using the written hard copy of the book, you could use these trace tables to walk through all the steps in the lines of code, but the textbook, or Revel, uses the online animation instead, which is very nice and really helpful. Now that gets me to an example quiz. I'm going to go on through that, and of course it'll be helpful for you if you work on those kinds of things. Now as we start working with data, we want to read input from the console, and we have a great Revel video here to tell us a little bit about doing that. So I'm going to refer you to that video where they're going to tell you about using system.in to read input from the console. So whatever the user types on the keyboard is what we're going to be reading in. Now here's an animation that steps through reading input from the console. We prompt our user for a value, and then we read in the value using the appropriate read parameter. Now at this point in our Java training, we want to talk about identifiers and the valid values. An identifier is anything that we name. So in Java, we name variables, we name classes, we name methods. Anything that we name is considered an identifier. Now we have some specific rules for identifiers. First of all, we can use letters, digits, underscores, and dollar signs. Our identifiers must start with a letter, an underscore, or a dollar sign. Cannot start with a digit. An identifier cannot be a reserved word, and you can see this appendix for a list of those. An identifier cannot be true, false, or null, and we can make an identifier of any length, but we want to be reasonable in our naming. Now they give some examples here of legal identifiers. And you'll always get a compile error if you're trying to use an illegal identifier name. So you'll get some sort of syntax error from your compiler. And then as a tip, it's recommended that you don't use identifiers with a $ character. We only like to see that in mechanically generated source code, so that's kind of a common convention. Now, whenever we need to store data in our program for use, we store it in memory, and we name these memory locations, and we refer to them as variables. So a variable is a named memory location that contains some data. So in this example, we've created a variable named radius and set it to value of 1. So variables are for representing data of certain types. And we want to tell the compiler or the system what type of data our variable can store. We do that by declaring our variable, and when we declare our variable, we specify the data type and then the name we want to give the variable. So here are some valid variable declarations. We also can specify a data type and then multiple variable names, and that's declaring multiple variable names of that specific data type. For example, here we declare variables I, j, and k all as integers. We also can assign an initial value to a variable when we declare it. This declares a variable named count and assigns a value of 1 to it. Same 2 sentences here. And we can also use a shorthand to declare and initialize variables of the same data type. So for example here, we declare a variable I is equal to 1 and j is equal to 2. A variable must be declared before it can be assigned a value. So in Java, we are type specific, and that means that we are strongly typed. We must declare variables and say what data type they are before we can use them. We also need to be aware of the variable scope, and the scope of the variable is dependent upon where the variable was declared. And this gives us information on where the variable can be referenced. So we'll be looking at variable scope as we progress. We have a self-check. I'm going to go on through it. So as you see in Java, we have to always declare our variables before we can use them. We're strongly typed, and that makes it a little more hard to code than some languages that are more loosely typed, like Python. Now, in this example here, we are going to assign some values to some variables so that you see some ways that this can happen. First of all, if we specify the data type before the variable name, we're declaring a new variable. If we don't, we're using a variable that already exists. In this case, x has already been declared, and we're assigning a value to it of y plus 1. Okay? Now we can use our variable in an expression, so we can set x equal to itself plus 1. We cannot go backwards. If we specify something like this, we're basically printing out the value of x after we've set it to 1. So it's the equivalent of setting x equal to 1 and then printing it out. And if a value is assigned to multiple variables, you can use this syntax like this, where we set I equal to j equal to k and all of them equal to 1. Okay, so may not be the easiest programming style to read, but it is viable. I'm going to skip past all of this and take a look at our different named constants. A named constant is a variable whose value will not change throughout the execution of our program. So one example of a constant would be the value of pi. We know that that's not going to change. When we declare a constant in Java, we use the keyword final. So we say final and then whatever data type it is, and then we want to name our variable using all uppercase and assign the value. So it's just a convention to use all uppercase when we're declaring a constant. So you can look through some of the example code there, working with our constant. And then naming conventions. When we're working with Java, it's important to follow accepted naming conventions. We always begin variable and method names with lowercase letters. We capitalize the first letter of each word for a class name, and we capitalize every letter in a constant, as we just saw. It's important for you to follow these naming conventions to make your program easy to read and easier to understand. Now, when we're working with different types of data, there are these different types available. So first of all, we have byte, and a byte can have a value of -2 to the power of 7 to 2 to the power of 7, or -128 to 127. This is an 8-bit number, and 1 bit is used for the sign, so we lose a bit there. So we have a limited range of values with a byte. We can have a short integer, which is 16 bits, so it takes up 2 characters, and it has a range of -32,768 to 32,767. Then an int data type is a 32-bit signed integer, this range of values. A long integer is a 64-bit signed integer. So of course we could use a long integer on a 64-bit operating system, which should be acceptable in most cases. If we're using some mobile development, we might be limited to 32-bit. Then a float is a number that is very large that's carried in scientific notation, and a double is also a 64-bit number that's carried in scientific notation, so we can get up to a very, very large value. So for scientific processing, we're going to use a float or a double. So if we read numbers from the keyboard, we have specific methods that we can use, and next byte reads an integer of the byte type. Next short expects a short integer. Next int accepts an int data type, and so forth. So we can try these different next commands as we're using our input scanner. So our input scanner is going to accept these different types of data for us to read. So try some different examples there. Now, as we're working with numeric data, we can do specific math type functions with our numeric data, as expected addition, subtraction, multiplication, division, and we can do remainder type math or modulus operations. So take a look at all of that if you're not feeling familiar with it. Now, if we want to do exponential type math, we're going to use the math class or the math library available to Java. And we'll look at that a little bit more in Chapter 4. But in this example, we used the math library, which you can see by us saying math dot, and then we use the POW method that's available in the math class or the math library. And the POW method expects two parameters. First is the base number, and second is the power. So that's going to give us 2 to the power of 3 as a result for that call to math.pow. So we can see that we can call math functions as well as doing math within our program. Now try the different examples as you're going through and see what they want. You have unlimited tries, so you can make sure that you're understanding what the textbook would like from you, and this is going to help you do the projects and stuff much easier. Now, in this section we want to refer to numeric literals, and a literal is any time I see data type information in my readily readable in my program. For example, in this example here, the number 34 and the number 0.305 are literals, and that is any time we have this constant value that appears directly in a program. Now, when we want to assign a value and we want it to be an integer, we can use a literal value. And sometimes we have to use some hex formats, which we'll look at here in the next chapter real quickly, and some different formats to get Java to understand what kind of data format we're talking about. So as we're working with doubles, notice that we have to make sure we're including a decimal place, and we can use scientific notation. Some great information there for you. Getting there. Okay, and then just as with any other programming language or math performing activity, we're going to use a standard order of operations to evaluate our expressions. So please look at the examples here and make sure that you're getting a clear understanding of the order of evaluation. And lastly, for Chapter 2, we have a case study displaying the current time. So this is another great opportunity for you to look at a video and follow along and try to code this program with the example, and let me know if you have any questions. That's it for Chapter 2. We'll take a look at Chapter 4 here in another video. Thank you.